Hello, my dear students. Good morning, all of you. Our subject is CHO 352. Section first, that is stereochemistry. In last previous lecture, we studied some basic concept about stereochemistry, some examples of stereochemistry. Today, I am going to teach you a pyrolytic elimination reaction. Which is also called as cis elimination reaction. Okay, as we know in cyclohexane, the chair conformation is more stable conformation. Suppose this is a chair form of this cyclohexane, which is more stable conformation. In that, some hydrogens are above the plane or some hydrogens are below the planes. Or some hydrogens are axial or some hydrogens are equatorial. Okay, in that, suppose if some hydrogens is in the cis means all hydrogens or any alkyl group or atom must be above the plane means it may be axial or it may be equatorial. Suppose above the plane it is denoted as a wedge line. Okay, this hydrogen is above the plane, hence it is denoted as wedge line, and this hydrogen is below the plane, it is denoted as a dotted lines. Okay, in that first, this hydrogen is axial, this hydrogen is axial hydrogen, and this hydrogen is equatorial hydrogen. Suppose in this carbon, this hydrogen is above the plane, which is equatorial in position. Okay, this hydrogen is above the plane but it is in equatorial position, and here this hydrogen is above the plane but it is a axial, and this hydrogen equatorial, which is outside the plane. Okay, next, this hydrogen is axial but it is below the plane. Okay, hence this hydrogen is axial but it is below the plane, and below the plane, as we mention or we denoted as a dotted lines. And in cis means one hydrogen is axial or one hydrogen is equatorial. In the cis means must be above the plane, above the plane. Any atom or group of atom must be above the planes or below the plane. It must be, suppose, axial 1 2 axial equatorial 1 2 axial equatorial, that is this hydrogen is axial, okay, which is above the plane, and this hydrogen is equatorial, which is also above the planes, means this hydrogen and these hydrogens are cis to each other. Okay, or this equatorial hydrogen and these axial hydrogens are cis to each other. Okay, you get it? Now suppose if I am taking some examples about pyrolytic elimination reaction, in that our stereochemical requirement is the eliminating atoms or group must be cis to each other, that is eliminating atoms. Suppose if we consider eliminating group, that is xanthates, some amines or tertiary amine or any acetate group. Now I am taking one examples about pyrolytic elimination reaction, that is cis 2-phenyl cyclohexyl xanthates. This is cis 2-phenyl cyclohexyl xanthates. In the stereochemical requirements of pyrolytic elimination reaction, the atoms or any group of atom must be cis to each other. Suppose if we giving some heating condition, and then we will get a olefins, that is carbon carbon double bond. Okay, one is major product or another is minor product. Suppose if we taking this example cis 2-phenyl cyclohexyl xanthates, in that the structure in cyclic form of the structure is cis 2-phenyl means cis means must be above the plane or must be below the plane. Suppose I am taking this pH group is above the plane and this hydrogen is at below the plane, and this xanthate is also above the plane. Suppose O C double bond S S C H 3 and this hydrogen is at below the plane. Okay, now the shear form of this cyclic structure is, because the chair form is more stable conformation in cyclohexane. Suppose this pH, okay, this pH is above the plane, as I mentioned here directly, pH, okay, it is above the plane and this hydrogen is below the plane. Okay, now this O xanthates group C double bond S S C H 3 and here is hydrogen. Okay, as in this reaction under heating condition we get two products. Okay, that is major product, one must be a major product or another must be a minor product. Okay, our condition in pyrolytic elimination reaction, it must be cis to each other. Okay, cis elimination reaction. Suppose the eliminating group must be cis to each other. Okay, and eliminating group, suppose this xanthates is our eliminating group and this is hydrogen which is also cis to each other. Now cis means both are as we show, both are at the above the plane, which is cis means it must be one is axial position and one must be at the equatorial position. Suppose this hydrogen is at axial position and this hydrogen, this xanthates group is at equatorial position, and here is also hydrogen but it at the equatorial position and this xanthates is also at the equatorial position. Hence the more favorable condition is the eliminating atoms or group are cis to each other and this hydrogen and this group xanthates are trans to each other, because this xanthates is above the plane and this hydrogen is below the plane. Okay, means they both are trans to each other, but this hydrogen and this xanthates group are cis to each other. Okay, under heating condition we get olefins. Okay, suppose we get two products, that is first one is, here is pH as xanthate groups is a, suppose under heating condition we get a carbon carbon double bond or olefin as a product. This is a major product, or suppose if hydrogen, and one is minor product. The minor product must be this hydrogen and this xanthate groups, because both are the trans to each other. As they are trans to each other, hence it gives a minor product because the conditions are unfavorable for the product, and this is a minor product and this is a major product. Okay, just remember one thing, the eliminating atoms or group must be cis to each other. Okay, it may be above the plane or it may be below the plane, but it must be cis to each other. That is this hydrogen and these xanthates are cis to each other, but this hydrogen and these xanthates are trans to each other, hence it gives a minor product. Okay, suppose if we under heating condition we get this product but it is minor, some less amount like 0 to 4% minor product, and here 96 to 100% as a major product, and this hydrogen and this eliminating group xanthate must be cis to each other, hence we get a major product. Okay, suppose this is the cis 2 phenyl cyclohexyl xanthates, in that the major product is 1 2 3 3 phenyl cyclohexene, and minor product is 1 phenyl cyclohexene. Okay, in the cis 2 phenyl cyclohexene xanthates, the major product is 3 phenyl cyclohexene. The stereochem, as we know the stereochemical requirements, we get this as a major product, that is 3 phenyl cyclohexene, and 1 phenyl cyclohexene as a minor product. Okay, suppose if I am taking cis, another example, that is trans 2 phenyl cyclohexene. trans 2-phenyl cyclohexene. The structure is like this. Suppose this is our ring. Trans 2-phenyl means one is above the plane, this pH is above the plane, and this xanthate is below the plane, like O C double bond S S C H 3, and this hydrogen is above the plane and this hydrogen is also below the plane. Okay, in that the shear form of this is like this. Okay, pH is above the plane and xanthates is below the plane. Okay, means O C double bond S S C H 3, and here is hydrogen and here is also hydrogen. In that we also get two types of product, but the major one, the product is under heating condition we get products. Okay, our stereochemical requirement is both eliminating atom must be a cis to each other, means this is also above below the plane and this is also below the planes, means both are cis to each other. It is this xanthate group is axial but it is below the plane, and this is equatorial hydrogen but it is also below the planes, hence both are cis to each other. Hence under heating condition we get a product like olefins or carbon carbon double bond. Okay, here is pH group and it is a 1-phenyl cyclohexene, 1-phenyl cyclohexene as a major product, and the minor product, here is also hydrogen, here is also hydrogen. Okay, and this hydrogen, axial and equatorial hydrogen, we get a minor product. Okay, or it must be, here is phenyl ring, one is hydrogen is a minor, and the name of this is 3-phenyl cyclohexene, 3-phenyl cyclohexene. In cis 2-phenyl cyclohexene xanthates, the major product is 3-phenyl cyclohexene, but in trans 2-phenyl cyclohexene xanthates the major product is 1-phenyl cyclohexene, because the favorable condition is both or the stereochemical requirements is both hydrogen and eliminating group are cis to each other. Okay, or it must be one is axial, one is equatorial.